With the release of the Koenigsegg Quark Electric Motor, we can safely say the Swedish company has outdone itself. Simply called the Quark, the new incredibly compact electric motor offers interesting glimpses into the simple ideas that typically usher in a new trend of technology in the EV industry. For an electric motor with such an incredibly small size, the Quark weighs just 28.5 kilograms and delivers 335 horsepower, with a peak torque of 600 pounds per square inch. Insane, right? Imagine putting such powerful motors on electric bikes in the future. That is going to be utterly amazing. So what led to this insanely powerful and compact Koenigsegg Quark? The origin story of Koenigsegg is quite unique, to put it mildly. Christian von Koenigsegg, who ended up naming the company after himself, got the idea to build his own car after watching a stop-motion animated movie on fast cars. So after raising $6 million from interested investors, what we now know as Koenigsegg Automotive was founded. And true to the founder's dream, Koenigsegg Automotive has since been focused on developing high-performance sports cars and engines. What caused the development of the Quark Electric Motor? From 1994 to 2006, the only manufacturing operation carried out at Koenigsegg's various facilities was the production of high-speed cars. However, in 2006, the company introduced the Koenigsegg CCX to the global market, but it was met with stringent safety and emission standards that the Swedish company simply had to meet. As a result, the company was forced to allocate some of its resources to the development of Koenigsegg engines and other related technologies. Interestingly, by taking over the designing and packaging of Koenigsegg motors to be used in Koenigsegg cars, the company gained the ability to stamp a unique identity on all Koenigsegg products, which of course was when the magic began. Over the years, Koenigsegg has released some truly advanced technologies that were developed in-house. However, whenever electric motors were concerned, Koenigsegg always opted for motors from its English supplier, YASA. It wasn't until the first quarter of 2022, after the company first unveiled its new 6-phase inverter that promised rich power density and efficiency, that we got the first glimpse of what a Koenigsegg electric motor looks like. Then the company teased the brilliant Quark electric motor with its innovative torque-power balance between radial and axial flux topologies. And this was when the world really started paying attention. How does it work? For an electric motor with such an incredibly small size, the Quark weighs just 28.5 kilograms and delivers 335 horsepower with a peak torque of 600 pounds per square inch and a nominal system voltage of 850 volt. After the first 20 seconds, the output of the Quark drops to 134 horsepower and 184 pound-feet of torque. So what do all these numbers mean? We'll get to that in a second. According to Koenigsegg, one of the key drivers for the development of this electric motor was to create a world-class drive unit that guarantees peak performance every time the Koenigsegg Gemera is used. In case you don't know, the Koenigsegg Gemera is a limited edition 4-seat hybrid car. As a result, the Swedish company ended up with a 660 horsepower Terrier, which is marketed as a self-contained torque V-vectoring electric drive unit. The Terrier, which weighs around 187 pounds, delivers 811 pound-feet of torque, features 2 integrated Quark electric motors, a massive Koenigsegg David 6-phase inverter, and other essential gear set. But all these do not explain what the Quark electric motor does or how it works. The best way to truly understand the Quark and how it works is to understand the idea behind its creation. According to the Koenigsegg electric motor design lead, Dragos Mihai Postoria, the Quark is designed to bolster the low-speed range of the Gemera, where you need it for brutal acceleration. The ICE then focuses on the high-speed range. What this means in terms of performance for the Gemera is a big power surge followed by a continuous record speed push to 400 kilometers per hour without any torque or power losses. The company's development lead, Andres Sekeli, further stated in a press release, "We constructed the shaft within the Quark out of 300M steel used in motorsports and aerospace. Direct cooling was chosen for its higher cooling efficiency and compact design. Even the rotor uses the renowned Koenigsegg Air Core hollow carbon fiber technology. We not only overcame the challenge of the Gemera's powertrain requirements, but also exceeded our goals of making it lighter and smaller than any electric motor in this class." So in summary, the Swedish company wanted to create a powerful drive unit for their Gemera car, but instead they ended up with a masterpiece that got everyone's attention in the automobile industry. By the way, drop me a like and subscribe if you haven't already. Now let's answer that question that has kept you waiting. How does the Quark electric motor work? The Quark electric motor is not only unique in its incredibly small size, the high versatility and efficiency of the torque to power to RPM to weight matrix of the Quark electric motor cannot be overemphasized. While originally created for use in a four-seater car, the Quark electric motor has other applications in the aerospace, marine, VTOL, and EV industries. This versatility is possible because the Quark electric motor does not require a step-down transmission. Usually, small motors with high revving power tend to have a high peak power-to-weight ratio and typically require a type of transmission to achieve the desired output RPM and torque. The implications of these setups are that they require an additional gearbox, more weight, and more complexity, which always result in energy losses caused by magnetic flux leakages. However, the Quark electric motor is not simply a small motor. The Quark motor integrated into the 660 horsepower Terrier drive unit offers reduced size and complexity without significantly taking power away from a high-performance car. This efficiency and power are achieved by increasing the rotor diameter against the bulk of the motor's stator. Koenigsegg also optimized the outer diameter of the stator to ensure no losses incurred due to leakage of extra flux. Typically, electric motors either feature a radial flux layout or an axial flux layout. Electric motors with a radial flux layout tend to offer more power with less torque. Axial flux electric motors, on the other hand, deliver a ton of torque but with less power. Radial flux motors are cheaper to build and are generally used in the production of electric vehicles. The Quark combines both layouts into what Koenigsegg dubs the thoraxial flux layout. The Quark brings the broad power band found in axial flux motors and the peak power of radial flux motors. The axial flux layout of the Quark allows for its compact size without any need for a reduction gearbox. So not only did the company manage to significantly reduce flux leakage, improve performance, and greatly reduce size, but Koenigsegg also created a powerful motor that challenges everything we know about the future of the EV industry. What next for the Koenigsegg Automotive? In a recent interview to talk about the reception of the Quark, CEO von Koenigsegg stated that the Koenigsegg has received several inquiries about the development of a power-dense electric motor and how the automobile industry can advance to the next level. The CEO also expressed the company's willingness to license the technology and design ideas behind the development of the Quark electric motor to interested parties. Koenigsegg Automotive will also look to accelerate its goal of transitioning into an EV manufacturer. An important determining factor will be how the company handles its production costs. As good and impressive as the Quark electric motor is, the high cost of production poses a significant stumbling block. The Quark is developed using a wide array of exotic materials, including the Quark features the carbon core hollow carbon fiber material, which is owned by Koenigsegg. The rotor on the Quark is also made entirely from motorsport-grade, high-strength steel. These two materials significantly contribute to the high cost of production. During the development and production of the first Quark prototype, Koenigsegg experimented with several conventional materials. However, the Swedish company decided against using such materials due to the massive reduction in peak RPM. Thank you for watching. Don't forget to like and subscribe. Also, click on the bell icon so you don't miss future uploads.